the chain rule. Whenever you have something to a certain power, you do not want to try to FOIL this 5 times. Very bad. Plus here you can't get a square root off of this binomial. So you have to have something called the chain rule. Now there's 2 forms of it. This is the one the book shows in the front. This is what it's doing. A chain is when you have a composite function. You have a function inside of a function. Do you see here how your inside is 4 minus x squared, the outside is 3 something to a fifth? Or kind of just ignore that 3. Something to the 5th power is the outside. The inside is 4 minus x squared. The basic idea is you derive the outside, leave the inside, and then derive the inside. That's what that's saying. You're deriving f, which is the outside, leaving g, and then you derive the inside. That's what this is saying too. U to the n, you derive u. That's normal, right? Except at the end, you derive the inside as well and multiply by it. That's the chain rule. It takes some practice. So basically, if I wanted to derive number 8 here, I'd put the 3 and just leave it out front for now. Okay? And then what I'm going to do is I'm going to treat this as u. Okay? So what I end up with is I derive u to the 5th. Think of this as u to the 5th. Is that okay? And it's u to the 5th, and u is 4 minus x squared. Okay, with the 3 kind of chilling out front. This is u to the 5th, and u is 4 minus x squared. So what's the derivative of u to the 5th? It's 5u to the 4th. Correct? Okay, what was u again? 4 minus x squared. But according to the chain rule, you also have to derive u. So what's going to go multiplied at the end? The derivative of u, which is negative 2x. So, oops, that should be prime. I'm sorry. It's y prime. So y prime, if we simplify all this, 3 times 5 times negative 2 gives us negative 30. I'm going to bring the x out front, and I have 4 minus x squared to the 4th. That is the derivative. Again, you look to see what the inside is. That's your u, basically. And then now I have u to the 5th. You derive u to the 5th, and you get 5u to the 4th. You plug u in, just leave it. And then you derive u and stick it at the end as a multiply. Let's do it again. Now, this is a product rule, by the way. I'm going to first rewrite this as what I did here is I took the 1/2, ignored it for a second. Is that okay? I'm going to wait to the end to deal with the 1/2. Makes it easier because you don't have to deal with fractions. Then, do you see a product? I changed the square root to a 1/2 power. Now, do you see a product rule? You see 2 things. Okay. So, y prime is going to be 1/2. And for product rule, we derive the first, so that's 2x. Leave the second piece. Plus, leave the first piece. And now to derive the second piece, do you see a chain rule? Do you see right here, you have u to the 1/2? So how do you derive u to the 1/2? It's 1/2 u to the negative 1/2. And what's u? U is still 16 minus x squared. And what's the last step? You derive u. So here, you integrate with u, then you derive, you derive with u, and then you derive the u at the end. So derivative of 16 minus x squared is negative 2x. Alright, so with all that, we now want to simplify this. Put the 1/2 out front. First step is this 2x is not going to the 1/2, so we just have 2x, still 16 minus x squared to the 1/2 here. Now, if we multiply all this, can you see how this 2 and this 2 is going to cancel? Can you also see that it becomes a minus because of negative, and an x times an x squared gives you x cubed? And then isn't it also going to be over 16 minus x squared to the 1/2? Sorry, my brackets are a little funky, small and big. Are we okay that the negative power drops it to the bottom? Now the next step, I want to try to combine this big mess. So to combine this big mess here, do you see how I'm going to have to multiply this piece right here by this denominator? When I multiply this piece by this denominator, this is going to be kind of hard for some of you, but you're going to end up with 1/2. When you multiply this times this, they're the same, right? What's a 1/2 times a 1/2 power? Becomes to the first power. So basically you just get 2x x minus 16 minus x squared. Again, you're going to multiply this value right here to top and bottom, so you can subtract the fractions. So when you multiply this to the top, it ends up dropping the power, luckily, and then you have to write this on the bottom because that's what you needed. And then you have this, which is the normal one over here. Okay, so next, can you distribute? And it looks like we have y prime equals 1/2. Can we combine and distribute? What I end up with is a 2x times negative x squared. Does that give you x cubed? So do you see how I have a 2x cubed and an x cubed negative? That means I have negative 3 x cubed, and then here you have a positive 32x. And on the bottom you still have 16 minus x squared to the 1/2. Okay, kind of crazy. Now, does a 2 come out of here to cancel with that 2? No. Could I pull an x out of the top? Yeah, but would that x I pull out of the top cancel with anything down here? No. You could do that, not necessary. Here's how that would probably be a good enough answer, but my final answer would probably look something like this. I would probably do something like x, pull an x out, negative 3x squared plus 32 over 2, and actually I probably would even put the square root sometimes. That's how I would probably finalize my answer. Right there would be my final answer to me. Again, you don't need the square root, you could leave it with a 1/2 power, but I would pull out the GCF. There's a reason in the future for that. A lot of simplification. It's a product rule with the chain involved.